This is a video that covers Worksheet 8, and all through the course, through the Learning Support class, we've continuously compared decimals, and we've had inequalities and all that. So the first part of this you should know how to do. Remember, you always place zeros to make the values exactly the same length, and then the opening always goes towards a larger number. We are going to use this in an application that you're going to use in your statistics where you're dealing with hypothesis testing. This is a very, very important handout because this will help you a lot with statistics. In hypothesis testing, we have something called a p-value. And we take and compare a p-value to alpha. Now, alpha is the area in the tail of our distribution. So what happens is, to determine if we reject a null hypothesis or fail to reject, we have to do a little comparison. And so here's what we're going to look at. If the p-value, we're going to write p-value, is less than alpha, okay, p-value is less than alpha, we're going to reject the null hypothesis. That's just, it's abbreviated H sub 0. Okay, the other one is if p-value is greater than alpha, then we're going to fail to reject. That means do not reject it. Fail to reject H sub 0. Okay, so you're going to compare. Now, there is a saying to help you remember this. If you'll learn this saying, it'll help you get these answers each time when you get into hypothesis testing. Here's the saying: if p-value is low, the null must go. So notice, if p-value is less than alpha, that we reject the null. So if p-value is low, the null must go. If p-value is high, the null will fly. If p-value is higher than alpha, we fail to reject the null. That means we don't reject it. So it's like this. We have what we call the null and the alternative statement, H sub 0 and H sub 1. The null is this one, okay? So if p-value is low, the null must go. That means we would cross that out and we would accept the alternative, okay? Here's the other one, H sub 0, H sub 1, the null and the alternative. If p-value is high, the null will fly. That means we circle the null, we reject the alternative, okay? So we're going to be doing that with several problems here. So I'm going to lead you through 2 of these, and then I'll let you do the other 2. So it says, determine for each statement if you reject the null or you fail to reject the null. So what we want to do is we first want to write out p-value and alpha, okay? So we need our p-value and we need our alpha. So in this case, p-value is 0.05. The alpha is your level of significance. It's 0.01. 0.01, okay? P-value and alpha. Now, notice they have the same number of decimal places. 5 is greater than 1, so p-value is high. So I'm going to come over to the side, write H sub 0, H sub 1. P-value is high, the null will fly. That means I'm going to circle the null, and I'm going to cross out this. So it says we got to determine, do you reject the null or you fail to reject? In our case, we failed to reject the null. You have to write this out. Fail to reject. Whoops, J-E-C-T, H sub 0. You're going to do this with each of these problems. Write down your p-value, compare it to the alternative, or to your alpha. If p-value is high, the null will fly. You got to write this out, okay? I was looking at another one here. Let's do this one. Let's go, I'll go ahead and do E, and then you can do F and G. Okay, p-value, I'm going to write it down. 0.160, and alpha, your level of significance, is 0.05. I need to place a 0 on the end to make it the same number of decimal places as this. Now 160 is greater than 50. P-value is high, so we come back over here, write h sub 0, h sub 1. P-value is high, the null will fly. There's another one that it did the same thing, cross this out. So we failed to reject the null. Okay, I'm gonna look. I think we got several. Let me check something. Let's see. We do. So I'm gonna go ahead and work out the next two to help you through this. We'll do these, okay? Be sure to write these out on your paper. You'll turn these in. I'm gonna check yours to make sure you're doing what I'm asking you to do. And then there's gonna be a whole page of these later that you'll do. So I'm just going to go ahead and do this one. Okay, p-value is 0.069. Our level of significance is 0.1. So 0.100. Now in this case, 69 is less than this. Okay, p-value is low. So h sub 0, h sub 1. P-value is low, the null must go. Okay? So in that case, we reject the null. It's always based on the null hypothesis, okay? The null. Okay, so you can do G. Okay, go ahead and finish out G. Okay, the next page. Let's look at this. Now this is our application of where you're going to be using this. So we got a statistical application. Now notice it says on this, they want you to, it says hypothesis testing is a procedure used to test statements regarding the characteristics of one or more populations. Sample evidence is used to perform hypothesis testing. And notice it says, we want you to identify the null hypothesis and the alternative. Now, something you need to know is the null hypothesis always has an equal sign, no matter what, okay? The null always has an equal. So here's an example. The probability equals 0.5, okay? H sub 0, probability equals 0.5. It always has an equal. The alternative statement, H sub 1, never has an equal. So it's either going to be a less than, it's going to be a greater than, or it's going to be a not equal to, okay? So what happens with these, they're going to ask you, it says to read this statement and write out your null and your alternative. But first it says write out the specific claim to be tested. So according to the U.S. Department of Health and Human Services, 51.4% of adults aged 55 to 64 have hypertension. A researcher believes the percentage is lower. So notice that. That part right there, that is our claim. This researcher believes that hypertension is lower than 51.4. So they want us to write out the specific claim. So here it is. When we write this out, the claim. Okay, so the researcher believes, that the percentage of adults, from age 55, from age, 55 to 64, 5 to 64, that have hypertension, that's high blood pressure, is less than 51.4%. That is our claim, okay? We're trying to test that claim. We want to know if that's true, okay? So now, write the claim in symbol form. So what that's telling us is we've got to write out our h sub 0 and our h sub 1. Now keep in mind, the null is always an equal, okay? And we're dealing with probability, so we're going to either do a p equals a number or a p is less than, greater than, or not equal to. With the null, it's always equal. So first of all, my null is going to be p equals, and it's the percentage is a decimal, so 0.514. And then the alternative is what the statement said. The alternative is less than. That's not 10, that's supposed to be than. Less than 51.4. So our alternative is going to be P is less than 0.514. Notice how these two always match. Those two will match, but the signs are different. And now it says using the expression. Well, I misread this. It says write the claim in symbol form. The claim was, let's mark this out. The claim was this right here. I didn't read what I was supposed to do. So there's your claim. Now we write out our statement. So this should be 0.514, and this one would be less than 0.514. 14. Okay, now what happens is you've got some pages over here that you've got several of these that you're going to do yourself, okay? Use the p-value method. Determine if you reject the null or you write out and then write out the conclusion, okay? And you've got some that's less than, you got some not equal to, you have a greater than, and we have a less than. So I'm going to come and do the first one, the less than, for you to lead you through this. So use the p-value method. That means compare p-value to alpha to determine if you reject the null. So my p-value is right here. So I'm going to do 0.0008. And then I have 0.0100. P-value alpha. Notice my p-value is less. P-value is low, the null must go. Okay, that means we accept this alternative statement. So it's going to ask you to write out a conclusion. So my conclusion would be, there is enough evidence to support the claim. There is enough evidence to support that, notice it's the mean, that the mean is less than 1.45. Okay, so notice when you're doing these, if you accept the null, then you would say there is not enough evidence to support that the mean is whatever. Okay, but in this case, there was enough evidence. If I had accepted the null and crossed this out, we would have said there's not enough evidence. So you're going to do that for all these right here. Okay, there's 4 of them. And then the last thing is on the last page, it's going to ask you to use something called a test statistic method. It's the same, it's actually testing hypothesis statements. You're going to use a bell-shaped curve. This is different from the p-value method. You're going to mark off. Notice this says the mean is less than. That means I'm going to mark off a tail over here. That's my critical value, is the part marking off the tail area of this. So in this particular one, notice my test statistic is a negative 2.473. That marks off that tail. Now what happens is I'm going to take my test statistic and place it on the number line. If it falls into the shaded region, we're going to reject the null. Okay, so if this test statistic, which is a negative 3.17, which does fall into there. Negative 3.17 falls into the shaded region, because I got the shaded region from this tail. Okay, this was, I meant from this this less than, which is the tail. If it falls in that shaded region, we reject the null. So we reject the null and we accept the alternative. There is enough evidence support, so you're going to write out the claim. If you got a, notice if you got a not equal, that's going to be a two-tailed test. It looks like this. Okay, and you've got a negative 1.833, and you got a positive 1.833. The shading region's in the tail. Okay, now you take your test statistic and you place it on the number line. Would it be in the middle, or is it going to be on the ends? If it's in the ends, you're going to reject the null. If it's not in the end, if it's in the middle, then you fail to reject the null. Okay, so anything in the tail region, reject. H sub 0. Reject H sub 0. You will have to take your test statistic and place it to determine if you reject. So you can continue that on through the other problems.